Welcome, beloved siblings, sciencing the day today with the man who, when I tell the story, is the world's greatest living physicist. Nick Gross, PhD, lecturer in physics at Boston University, as I say, the world's greatest living physicist. But
I like the stories you tell.
when I see that we both got the NASA shirt and the hat memo, I mean, obviously, how can you obviously in touch with deeper physical forces than most of us can even imagine. You got manipulations going down there in the quantum realm. You see the quantum
Fields and wave functions. Yep.
I understand. This particular week is what we are calling here on Science Today Unification Week.
Excellent.
So yesterday I talked with Professor Ahmad Sadri about how the 330 million gods of Hinduism got reduced down to 2 and then down to 1 when they got to Persia. But I wanted to talk about because people like you and your ilk are forever talking about this grand unification theory. You want one beautiful, perfect, elegant theory of everything. Is this fair?
Yeah. There are certainly people of my ilk who want that. Yes, and I would say that I'm of that camp, church, religion.
All right. Well, first of all, is there any reason to believe that there is one grand unified theory of everything in physics?
That's a good question. It is kind of a tenet of faith, though there's lots of progress that has been made towards that. And so, for example, starting with Newton unified motion here on Earth and motion in the heavens, so that with both his theory of motion and the universal theory of gravity, he was able to explain why an apple falls, why the moon orbits, why comets orbit in their own ellipses, why tides happen, all these other things that are going, all the planetary motions, Kepler's laws, et cetera, et cetera, et cetera. So suddenly you were like, holy smoke, all these things that happen because of gravity all have one way of explaining them, and I can use, not only that, I can use the same mathematics. And sometimes I can simplify the mathematics, but I can use the same mathematics to explain them all. Right?
Okay.
So a parabolic motion of a thrown ball, right, and the moon's orbit,
right,
and comet's orbit, which, the moon's orbit's roughly circular, planetary orbit's roughly circular, parabolic motion of a thrown ball, well, it goes up and comes back down. Comet's orbit is this, funky ellipse.
Right.
All those things get explained. And then Einstein comes in and explains a little bit. He I would say, extends the model, right, to explain, because actually Mercury doesn't work in Newtonian theory. I don't know if you knew this, but Mercury's kind of was a rogue child for a little while until we wrangled it with general relativity. So, and that explains why Mercury's orbit is the way it is, and explaining all the other things at the same time.
So, all right. So what I think I hear you saying is that the fact that Newtonian physics can explain a whole bunch of phenomena can be explained and their behavior predicted by a single theory, by just a few equations, is a hint that there's some fundamental simplicity baked into the nature of the universe.
Right. And then the same thing happens with electricity and magnetism with Maxwell.
James Clerk Maxwell.
Combining electric phenomena and magnetic phenomena, and then showing about currents and how currents and magnetic fields are related. And then, and by the way, all of that can also show you how light is made. Right? And it's like...
But let me say, I would also think that the phenomenon of the Big Bang itself is a reason to think if at some point the universe was at a point of infinite density, every freaking thing was at a point of infinite density, and then boom, that the boom itself would be that force, that thing, that the theory that would explain that boom should explain everything else. Is that not right?
That's certainly what cosmologists and particle physicists are working on.
Yeah, I mean, so that's
in a lot of that. So this is your favorite, standard model, right?
Yeah.
Standard model is yet another example of taking a whole lot of disparate things,
right,
and putting them all together and saying, hey, we can describe all these things by just the Higgs boson and the physics that we want to put around it. So, and in fact, electricity and magnetism is wrapped up in that as well.
But now let me ask. So, our speaking of cosmology, the world's second greatest physicist, Neil deGrasse Tyson, we could say he posits that maybe physicists look for this single unified theory because we're just too stupid to imagine that the world is too complex for us to grasp. That we're it's because it's a function of our own limits as humans and the fashions of physics.
So I think that's part of the thing is that we try and see patterns in the world, and it's very, very tempting is the wrong word. It's very, very seductive that gravity got and gravitational things got unified, and then E&M got unified, and then not only that, but then all this particle physics also includes E&M, and that all got unified. And so I think the big questions that are left from we've got dark matter, and I don't.
We're not going there. Don't even go there yet.
The big
never mind. That's most of the universe.
Yeah, it's trivial.
Yeah, right.
The big thing that's left is that gravitation, so general relativity, and the standard model. People have been trying to put that together, and there's square peg, round hole. It doesn't quite fit, and so that's been a little bit of frustration, right? And so that's what leads one to go, maybe this isn't going to work, but
or just maybe we're not smart enough to do it,
or maybe we're not smart enough to do it. Yeah, I don't know, or somebody hasn't come up with the right conceptualization yet. I mean, there's string theory.
Yeah,
right?
Yeah.
So that is.
But I
working on trying to do that.
But I think I see you pushing back on this notion that we're not smart enough to do it. I think I see my buddy Nick saying you're not willing. Like the idea that maybe we're not that smart.
We keep making progress.
Well,
I mean.
Okay, on that note, there is no better way to end science today than that. We keep making progress. We're just a bunch of knucklehead apes, but among the least knuckleheaded of us is my buddy, Nick Gross, PhD, lecturer in physics at Boston University. Thank you so much, dear brother.
Thank you, Aaron. It's always a pleasure to talk to you.
And have a great time up there in Boulder. When are you coming back?
I'm coming back.
I mean, going back to Boston.
I'll be back in Boston at the beginning of August. So,
okay.
And where are you?
Huh?
Where are you?
Oh, I'm in my backyard with the chickens.
Really? Okay.
Thank you immensely much for watching, beloved sibling. I post new sciencey, optimistic videos every Monday through Friday. If you enjoyed this one with my ace droogie, Nick Gross, please smash that like, subscribe to the YouTube channel, and share with someone you know who might enjoy some sciencey optimism. I am Aaron Freeman. I am a sciencey optimist, and I hope you have an out-of-this-world time as you continue to science the day.